Figure 1 shows an open tank in the shape of a triangular prism. The vertical ends ABE and DCF are identical isosceles triangles. Angle ABE is equal to angle BAE 30 degrees. The length of AD is 40 centimeters. The tank is fixed in a position with open top ABCD horizontal. The water is poured into the tank at a constant rate of 200 centimeter cube per second. The depth of the water t seconds after filling starts is 8 centimeters. So what this question is saying that this is an open tank with a shape of a triangular prism. The vertical ends ABE and DCF are identical isosceles triangles. So this side of ABE and this side of DCF are identical isosceles triangles. Angle ABE is equal to angle BAE. So this angle of ABE, which is 30 degrees, is equal to angle of BAE, which is also 30 degrees. The length of AD is 40 centimeter, this side is 40 centimeters, and the top ABCD is horizontal. So this top ABCD is horizontal. Water is poured into the tank at a constant rate. So water is poured into the tank like this from the top at a constant rate of 200 centimeter cube per second. So the rate at which water is poured is 200 centimeter cube per second. And after t seconds, the depth of the water is 8 centimeters. And this is shown in figure 2. After t seconds, the depth of the water is 8 centimeters. In the first part of the question, I need to show when the depth of the water in the tank is 8 centimeter, the volume V centimeter cube of the water in the tank is given by the equation V is equal to 40 square root 3 h squared. So what this first part is saying that after t seconds, the water in the tank is at a depth of h centimeter, and that in this whole figure would look like this. This is the water in the tank with depth of 8 centimeter. And I need to show that the volume of this water is 40 square root 3 h squared. So to show this, I'll use the formula for volume in a prism, which is this. And to use this formula, first I'll need to find the area of this triangle. I'll need to find the area of this triangle. To find the area of this triangle, which represents the water in the tank, I'll calculate this third angle. You know that the sum of angles in a triangle are equal to 180. So for this triangle, 30 plus 30 plus this angle, let's name this angle as theta. So plus theta would be equal to 180 degrees. This gives me the value of theta as 120 degrees. So this angle is 120 degrees. It is also told that these triangles ABE and DCF are isosceles triangles. Since these two angles are the same, meaning these two sides AE and BE are same. So what I can do over here is that I can divide this triangle into two parts, and that would give me this angle as 60 degrees and this angle as also 60 degrees. And if I take this part of the water, I will get a right angle triangle. In this triangle, this side is the hypotenuse, this side is the opposite side, and this is the adjacent side. I am concerned with finding the area of this triangle, and to find the area of a right angle triangle, we use this formula of area is equal to 1/2 times base times height. So I need to find the length of this base. So I'll apply right angle trigonometry over here. You know that tan theta is equal to the opposite side divided by the adjacent side. The adjacent side is h and the angle is 60. So tan 60 is equal to the opposite side divided by h. Tan of 60 degrees is square root 3, and multiplying both sides of the equation by h would give me the opposite side as h square root 3. So this side is h square root 3. So the area of this right angle triangle would be equal to 1/2 times the base, which is h square root 3, times the height, which is also h. H times h is h square, so the area is equal to 1/2 h square root 3. This is the area of this part of the water. To find the area of this complete triangle, I'll multiply this area by 2. 2 divided by 2 is 1, and so the area of this side comes out to be h square root 3. In order to find the volume of this water, I will multiply this area that we found by the length of EF, and that would give me the volume of this water. The length EF would be equal to the length AD, so this would be 40. So the total volume of this water would be equal to h square root 3. This is the area of this cross section of water times the length, which is 40. So the total volume of this water comes out to be 40 square root 3 h square. And this was the equation that we needed to show in the first part. So this is the answer to the first part. I have shown that the volume of this water is equal to 40 square root 3 h square. In the next part, I need to find the rate at which h is increasing when h is 5. So I need to find the rate of change of h, meaning I need to find dh upon dt. It was told in the question that water is poured into the tank at a constant rate of 200 centimeter cube per second. Centimeter cube is a unit of volume, and the rate at which volume was poured into the tank was 200 centimeter cube per second. So in the question it was told dV upon dt, the rate of change of volume was equal to 200. So for the second part, I can use the chain rule over here, which has this formula. But instead of dy and dx, I have an equation of v and h. So I can find dv upon dh and equate it to dv and dh here, and in the remaining places dt and dt. So this is the chain rule that I'll be using here. I don't have dv upon dh, but I can find by differentiating this. If I differentiate this, dv upon dh would be equal to 2 comes down to get multiplied by this. So 2 times 40 square root 3 times h. Multiplying 2 by the bracket would give me dv upon dh is equal to 80 square root 3 h. So this is dv upon dh, it is 80 square root 3 h. And dv upon dt, the rate of change of volume is given to be 200. So 200 times dt upon dh. Dividing both sides of the equation by 200 would give me 80 square root 3 h divided by 200 is equal to dt upon dh. Next, the value of h is given to be 5. So I'll replace this h with 5 and I'll get 80 square root 3 times 5 divided by 200 is equal to dt upon dh. 5 divided by 200 is 1 upon 40, and 40 divided by 80 is 20. So this is dt upon dh is equal to 20 square root 3. I needed to find the rate at which h is increasing. So meaning I need to find dh upon dt. So I'll reciprocate this and I'll get dh upon dt is equal to 1 upon 20 square root 3 centimeters per second. This is the answer to the second part of the question.